Hello everyone, welcome to another video of comprehensive biology learning. In today's video, we will discuss how do we derive Newton's second law of motion. Here, by derivation, I mean the mathematical expression or the equation of second law of motion. The Newton's second law of motion states that the rate of change of momentum is directly proportional to the force applied on the object. It means how much does the momentum change with time directly depends upon how much force is applied on the object. Now, this term momentum means a product of mass and velocity. Like if we apply force on an object, depending upon the mass of the object, the velocity changes. And this effect of applied force is nothing but the momentum, and it is represented by small p. Now, for deriving the Newton's second law of motion, we should first understand a case. Let's understand the case. Let's say that there's an object on which we apply a force F and the object moves forward and gets displaced by a displacement S. Let the mass of the object be m. Now we are considering two positions. Position 1, which is the initial position, and position 2, that is the final position. Now as we have applied force, certainly the object would have gained some momentum. We have to find out how much did the momentum change in between these two positions. So now let's look at these variables at position 1. Mass of the object remains m and m in both the positions. Velocity, let the initial velocity at position 1 be u and at position 2 be v. So the momentum, which is p1 at the initial position, will be a product of m and u, which is mu, and the final momentum, which is p2, will be a product of m and v, which is mv. Now, what do we remember from the statement of second law? We remember that the rate of change of momentum is directly proportional to the force applied. We will subtract the first momentum from the second one, p2 minus p1. Mind this thing, as rate is written. Rate means how much does the momentum change with respect to time. So p2 minus p1 upon t is proportional to f. If it means if f will increase, this will also increase. As we know that p2 is equal to mv and p1 is equal to mu from our previous understanding. If we put these values in this equation, it will be mv minus mu upon t is directly proportional to f. If we take m as common, it will be m in bracket v minus u upon t is proportional to f. And from the first equation of motion, if you remember, v minus u upon t is nothing but a, which is acceleration. So we can write, if we can substitute this value here, it will be m into a is directly proportional to f. Hence, we can write it like this: F is proportional to ma, which means the applied force is directly proportional to the product of mass and acceleration. Let us replace this proportionality with a constant. So, F is equal to k into ma. The value of k is 1. Hence, the formula comes out to be F is equal to ma. This is the mathematical equation for the second law of motion. If you have any doubt in this, you can always mention it in the comment box. Thank you.